Welcome back. Let's go. We're gonna go ahead and talk about continuity intermediate value theorem. This will be our second lesson on this. So let's go ahead and refresh what the intermediate value theorem states. It states that if a function is continuous on a closed interval, and f of a and f of b are not the same, so f of a, f of b, continuous, right? So it's got to be always defined in between. And if k is in between a to b, f of a and a to b, so notice in between these guys, then there must be a c in between the a to b on the x, such that f of c gives k. Okay? So, example letter A. Determine if the intermediate value theorem holds. In other words, if it can be applied to this problem for the given value k. If the theorem holds, find a number c for which f of c equals k. If the theorem does not hold, give the reason. So let's go ahead and do this. So the easiest thing to do was just evaluate 2.5. In other words, this is 2.5. 1 over 2.5 minus 2, and that is 1 over 0.5, and that is 2. F of 7, that is 1 over 7 minus 2 is equal to 1 over 5, and that is 0.2. Okay? So it says there, our k is equal to 1/4. So if I draw a picture, let me see. 1, 2, 3, 4, 5, 6, 7. Here is 2.5. Here is 7. Let me do that in black. 2.5, 7. At 2.5 we have 2. 1, 2. At 7 we have 0.2. So really, really small right there. So the graph, I don't know how the graph looks like. Maybe it looks like this. Something like that. Okay? Is there a line? Is there a line k equals 1/4, which is a 0.25? Is there a line that crosses in between these 2 points right here? And the answer is yes, because 0.25 is in between 0.2 and 2. So the theorem does hold. So it does hold. So what do we have to do next? We have to find the c in which provides us 0.25 for the k. So we have to say that f of c is equal to 0.25, and well, the function is 1 over x minus 2 is equal to 0.25. Now we have to find the x that provides us 1.25. So here's what we're going to do. This is the easiest thing to do. Anytime the rational function, a fraction with your x in the bottom is equal to a number, you can flip the fraction. Remember that this is actually 1/4. You can flip both sides of the equation, and that you have x minus 2 is equal to 4, and that makes things a lot easier. Instead of doing the whole butterfly method, it's too complicated. So x is equal to 6. So at x equals to 6, x equals 6, y equals 1/4. The intermediate value theorem holds for this problem. Let's go ahead and continue to number 2. Number 2 says now we have this quadratic here, and it says that is there a line y equals, or is there a f of c that equals 1? Is there a c that can give me a 1 in between 0 and 5, in between this interval? Okay, well, let's figure that out. So it's f of 0, which is 0 squared minus 3 times 0 minus 4, and that is negative 4. F of 5, which is 5 squared minus 3 times 5 minus 4, that is 25 minus 15 minus 4, um, 6. So here's the y value. Is 1 in between -4 and 6? Yes. Okay. So there does exist an f of c that provides a 1 in between 0 to 5. So let's figure that out. So x squared minus 3x minus 4 is equal to 1. The easiest thing to do is subtract 1. So now we have x squared minus 3x minus 5 is equal to a 0. Is this factorable? I'm praying that it's factorable. Because if not, we have to use a quadratic equation. Two numbers that multiply that give you -5. We're going to say it's, well, it's not factorable. Okay. We got to use a quadratic equation. So it's going to be negative b. So it's a, b, c. So it's going to be a negative -3 plus or minus the square root of -3 squared minus 4 times a times c all over 2a? Yeah, all over 2a. Okay, yeah, 2a. 2 times 1, which is 2. So it's +3 plus or minus the square root. Well, I'm going to go ahead and do some calculations here. That's a +9 plus a square root of, no, plus 20. So that's really 29. 20 is not a perfect square. So we're going to leave it like that. All over 2. Well, 29, the square root of 29. So the square root of 5 is, I'm sorry, the square root of 25 is 5. The square root of 36 is 6. So the square root of 29 must be somewhere in between 5 and 6. So it's got to be one of these two answers. It cannot be both. Well, if this is 5-ish, 3 plus 5-ish over 2, or maybe it could be both. We would probably need a calculator for this, so I'm going to see if I have one here. 3 plus square, no. Okay, square root of 29. 29 square root of, okay, 5.38. Okay, I'm gonna go ahead and do 5.38. So 3 plus 5.38 divided by 2. This is 4.19. What am I doing? Okay, the next one is 3 minus 5.38 divided by 2. This is negative 1.19. Now notice, this is my x value, this is my other x value. I need to pick an x value that falls in between 0 and 5. I cannot choose that one. This is my solution. So my c is equal to 3 plus the square root of 29 all over 2. And that is the c value that provides me k is equal to 1.